This is an experiment. We are going to demonstrate how to use a timer, time relay in controlling the hydraulic cylinder movement. So here, this is a hydraulic cylinder that is vertically placed here. This is a vertically placed hydraulic cylinder that is stroke is 20 centimeter or 200 mm is a stroke. And we are using two sensors here to control its movement. That is, this is B1 sensor and this is B2 sensor. And to control the direction of the cylinder, we are using 4x3 direction control valve. So this is a 4x3 direction control valve. That is actually G-spool valve is used. It is double solenoid. And to control the speed of the cylinder, we are using flow control valve. Okay. And to indicate the pressure, there is a pressure gauge is used. And this is a hydraulic circuit setup. And in the bottom, that is hydraulic power pack is there, hydraulic power pack that is going to supply power to the hydraulic circuit. So by pressure can be set in the circuit, that is using the pressure relief valve. Maximum pressure can be set in the pressure relief valve. And here in this circuit, the requirement of the hydraulic movement is by operating a push button. So it is there in the electrical circuit. This is electrical circuit designed. In the electrical circuit, there is a power distributor is there, that is 24 volt DC, positive negative is there, and then switch, push button and toggle switch. But in this circuit, we are using only push button. Two switches we are using, one for on and one for reset. And these are the relay boxes, K1, K2, K3. So three relays we are going to use, K1, K2, K3, and there is a time relay box is there. This is a time relay. This is a time relay, on delay timer is used. So in this experiment, the requirement of hydraulic movement is by operating a push button, cylinder should extend or cylinder should move upward. But when it reaches B1 sensor, it should stop for some time. That time can be adjusted using the timer. In the timer, there is a knob. In the timer, there is a knob where you can adjust the timing here from 0.5 seconds to 15 seconds is the maximum time. So now I adjusted approximately around 3-4 seconds of time. So the requirement here is by operating a push button, cylinder will move upward till B1 and it will wait for the time set in the timer. After the time, again it will move upward, and when it reaches B2 sensor gives the signal to the cylinder to move downward. Okay. So here requirement is by operating push button, cylinder will move upward till B1, wait for the time set in the timer, and then move upward again. When it reaches B2, it should automatically retract to home position. So this is one cycle. So by click of a push button one time, this cycle should complete. One cycle should complete. If you want to take one more cycle, if you want to start, then you have to press reset button here. There's a reset button. Then only you can able to start one more cycle. That is how the circuit is designed here. That is the experiment number 11. Okay. So now it is time to show the working. So we're going to switch on the motor. So now hydraulic power is there to the circuit. Now I'm going to operate the first button here. This button I'm going to operate and see the movement here. So it is extended till B1, move to B1, and after B1 again it was moved upward and then return back. So I'm going to press reset button here, and then press one more time. So if movement is very fast, then we can control the speed by operating the throttle valve. So again, one more time, I'm going to operate the start button here. Reset, first you have to reset, then start. Yeah, this is the complete working of the circuit, and this circuit is rigged up by the students, final year students of SJCET College Chikballapur. These are the students who involved in building up the circuit, both hydraulic circuits and electrical circuit. This is pneumatics lab, and this is a PLC laboratory, but students are working on building of hydraulic and pneumatic circuits in the software.